Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron as sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. We have developed an interface of 2 relays with microcontroller. Now we'll write a program to control the status of this lamp. This lamp is of 220 volt AC. We'll write a program to switch on and switch off this lamp with the help of this relay. We'll use these switches to control the status of the relays. Here we have switch 1, switch 2, switch 3 and switch 4. We'll use switch 1 to switch on the relay 1, switch 2 to switch off the relay 1, switch 3 to switch on the relay 2 and switch 4 to switch off the relay 2. But before writing this code, let's see how different sections of this prototype is connected together to perform this task. Here we have 2 relays, that is relay 1 and relay 2, which we have wire wrapped in our previous session. Here we can see digital output 1 and digital output 2. These 2 inputs to the transistors are connected with microcontroller from port RC4 and RC5. Here we can see we have 2 outputs, that is digital output 1 and digital output 2. Pin number 23 and 24 of the microcontroller. And here we can see 4 push switches are connected with the microcontroller, that is digital input 0, digital input 1, digital input 2 and digital input 3. And here we can see all 4 switches are connected with port D, that is port RD4, RD5, RD6 and RD7. We'll use these switches to control the status of this lamp. Here we can find the wiring arrangement of the circuit that we have created to control the status of this lamp with the help of this relay. We have applied the phase of the 220 volt to the one end of the relay, that is the common point. And we have connected the lamp with the normally open contact of the relay. And here we can see neutral is directly connected with the lamp. We have also interfaced the 8 LEDs with microcontroller with the help of ULN2803. We'll also use 2 LEDs to show the status of the relays. We'll use LED 8 to show the status of relay 1 and LED 7 to show the status of relay 2. And here we can see LED 8 is connected with port RB0 and LED 7 is connected with port RB1. Now we'll start writing the code of our project in MikroC. We'll go to the project, new project, standard project, and the project name is relay control. And the project folder will be here in MikroC projects. We'll create a new folder, that is relay projects. Okay. Device name is PIC16F877A and the device clock frequency is 10 MHz in our case. Okay, next. Finish. And here we have the main routine starting from void main. First we'll add some comments and assignments to our program. Here we have assigned the name to our project, that is relay control project. Now we'll add some assignments to our program. Now we'll add some ports assignments. We'll start from define, relay 1, and we know that relay 1 is connected with port RC4, so we'll write port C.F4. So we have assigned the name to port C4, that is relay 1. Now we'll define relay 2. And we know that relay 2 is connected with port RC5, so we'll write. So here we have assigned the name to port RC4 and RC5, that is relay 1 and relay 2. Now we'll define the switches. Define, that is switch R1 underscore on. It means the switch that will switch on the relay 1, and this switch is connected to port RD4, and here we can see digital input 0 is connected with port RD4, so we'll write port D4. We'll copy this assignment from here, Control C, and we'll paste it here, Control V, and we'll change the assignment, that is switch relay 1 off, and port is port RD5. We'll copy the assignment once again, Control V. Now we'll change the assignment here, that is switch relay 2 on, and the input port is port RD6. We'll paste it again, Control V, and we'll change the assignment, that is relay 2 off, and this switch is connected to port RD7. Now we'll assign the names to the LEDs, that is define LED underscore R1. It means the LED to show the status of relay 1. So we'll write port B dot F0. We'll add another assignment. LED underscore R2, port B1. Now here we have completed all the assignments required to write our program. And now we'll write our main program. And here we have our main program. We'll write a while loop in our main program. That is while 1. And we'll write the while loop between these two braces. But before while loop, we'll assign the directions to the port which we are using in our program. So here, before while loop, we'll write try state for port C4, that is press C F4 equals to 0. It means that port RC4 is configured as output port. Here we will write a comment in our program, that is port C4 is configured as output port. Now we'll assign the direction to the port RC5. So we'll write trace C dot F5 equals to 0. It means that port RC5 is configured as output port. So we'll add a comment here. Now we'll assign directions to other ports, that is trace D dot F4 equals to 1. It means port D4 is configured as input port. We'll add comment here. Port D4 is configured as input. Now we'll copy this line from here, Control C, and we'll paste it here, Control V, and we'll change the port, that is port D5 equals to 1. Port D5 is configured as input port. So here we'll also change the comment. We'll paste the line once again and we'll change the port, that is port D6 equals to 1. Port D6 is configured as input port. Control V, port D7. Port D7 is configured as input port. Now I'll assign the direction to the LED ports. Trace B dot F0 equals to 0. It means port B0 is configured as output port. Now we'll copy this line from here, Control C, and we'll paste it here, Control V, and we'll change the port, that is port B1 equals to 0. It means port B1 is configured as output port, and we'll also change the comment here. Now start writing our relay control program in while loop. So here we'll call a subroutine, that is relay control routine. So we'll write relay underscore R. We'll add a comment here, call relay control routine, and we'll write the relay control routine before main program. and here we'll write a subroutine to control the status of relay. So we'll write void relay underscore r, and we'll write the relay control subroutine between these two braces. So here we'll write if switch relay 1 on, control C, and we'll paste it here, control V, equals 0. As we can see from this diagram, the switches are connected as active low logic. So if we'll press the switch, the state of the input will be low, and if the switch will be released, the status of the input will be high. That's why we are checking that if switch 1 for relay on is low, then our program will come into these two braces. So here we will write, that is relay 1, control C, and we'll paste it here, control V, equals to 1. And from the schematic we can see that if port RC4 will be high, the relay will be on. That's why we have written that relay 1 equals to 1. So if port RC4 will be 1, so relay will be on. Now we'll check the status of switch 2. So we'll write if switch relay 1 off, control C, and we'll paste it here, control V, equals 0. So our program will come into these two braces, and here we'll write relay 1 equals to 0. Now here in this if statement, we'll also switch on the LED to show the status of relay 1. So we'll write LED for relay 1, control C, and we'll paste it here, equals to 1. So the LED will be on with relay 1, and we'll copy this statement from here, control C, and we'll paste it here, and we'll change the status of the LED, that is 0. So if the relay 1 will be off, then the LED to indicate the status of relay 1 will also be off. Now we'll copy these two if conditions from here, control C, and we'll paste it here, control V, and we'll change the assignments for these if conditions, that is relay 2. Here we will change the relay 2. Here we will also change the assignment, that is 2. If switch for relay off will be 0. So relay 2 will be off, and LED 2 will also be off. Now here we can check if the switch to switch on the relay 1 will be 0, then relay 1 will be on, and the LED to show the status of relay 1 will also be on. But if switch 1 relay off will be 0, then relay 1 will be 0, and the LED to show the status of relay 1 will also be 0. If switch R2 on will be 0, then relay 2 will be on, and corresponding LED will also be on. If switch R2 off will be 0, then relay 2 will be off, and the corresponding LED will also be off. Now we'll compile the program and we'll observe the result of this program on our prototype. So here I'll compile the program. Here we can check that there is no error in our program, and the hex file is generated successfully. Here we can check from the schematic, the middle jumper for power supply is for LEDs. First I'll change the jumper setting. So here I have selected the jumper setting to apply the power to these LEDs. Now I'll connect Picket 3 programmer with the prototype. Now I'll run the Picket 3 programmer software. Okay, we'll go to the file, import hex, and here in MikroC projects we have a folder that is relay projects, and here we have the hex file that is relay control. Hex file is successfully imported. Okay, right. And now we'll power up the prototype and we'll observe the result of our program. So if I'll press the switch 1, here we can check LED is on and the lamp is also on. So if I'll press the switch 2, relay is off, LED is off, and the lamp is also off. Now we'll connect the lamp with relay 2. First we'll power off the prototype. Now we'll power off the prototype once again, and if I'll press switch 3, here we can see LED 2 is on and the lamp is on. And if I'll press the switch 4, here we can see the LED is off and the lamp is off. So we have written a program to switch on and switch off the status of the relay, and also to control the status of the lamp connected with the relays. In this manner, we can switch on and switch off different types of load with the help of these relays. We can switch on lamps, we can switch on heaters, we can switch on fans. So we can switch on and switch off different type of electrical devices connected with the relay.